right, your next job is to calculate the net present value, internal rate of return, and a regular payback period. So if you look at the free cash flow, so that's the thing you're gonna construct the variable based on. So for the first one, the easiest one is internal rate of return. That's pretty simple. You just take IRR, that kind of function, and then select all the free cash flows. All right. So your IRR is actually 17.2%, which is above the required return. The required return basically is a minimum return you need to make in order to carry on the project. And since the IRR is greater than 9%, so this is a good project. The next thing you should do is NPV, or net present value. So you're going to use the NPV function of Excel, and the required return is 9%. And then you see the hint tells you need to select from a value 1 or cash flow 1. So we need to start from the first year's cash flow. Does that mean we're going to ignore that? No. We are going to add the cash flow 0 outside the NPV parentheses. Okay. So this is your NPV for the project. So it is a positive, which means you are also making money. If you want to calculate the regular payback period, this could involve a little bit more process. Okay. So you need to get the cumulative cash flow. All right. So for the first year, the cumulative cash flow is just itself. And then as a year goes by, you just keep adding the new cash flow to the cash flow in the last year. Okay. So after first year, after you make this $268,000, your balance is negative 982, which is reduced. You can also treat cumulative cash flow as an ending balance of each year. All right, and then you just drag it all the way. So as you can see that you just keep adding the free cash flow you made in the new year to the ending balance of last year, and then you get the ending balance of this year. So you will see that between the third year and the fourth year, your balance get paid off. So your regular payback period should be equal to 3 plus a fractional number. It's going to be 3 point something. It's less than 4, greater than 3. So how do you get the fractional part? You will need to use the remaining balance after third year, all right, divided by the money you make in the fourth year. So you're going to use a part of a fourth year's money to pay back the full amount of a third year's debt, all right? And make sure everything is converted at an absolute value. ABS is for absolute value. And then you're going to use this remaining balance of a third year divided by the money you make in the fourth year to get the fractional part of payback period. Okay, so your payback period is actually 3.78 years. So it's going to take 3.78 years to get this initial investment paid back by using the positive cash flow you receive each year. All right, so that basically concludes your first question of getting the IRR, NPV, and the payback. Now we're going to conduct a scenario analysis, and we're going to estimate different NPVs based on different cases. So what I want you guys to do here is actually to replace the price per unit and cost per unit with the information given in the context. Okay, so I'm going to copy this table and paste it to Excel. All right, so these are the 3 cases I'm going to analyze. So I'm going to replace the price and the cost and then record my NPV for 3 times. The thing is, I rather do it using the scenario analysis function of Excel. So I need to hit data, right? And then I do a what if analysis, and I'm going to do scenario manager. Okay, that's a perfect tool to do scenario analysis of capital budgeting. All right, so I'm going to add a first scenario, and I call it worst case. And then I'm going to change the 2 cells. One is the price, and another is the cost. All right, separate them by comma. So B5 and B7. Okay. And then I'm going to change it to 3, and B7 I want to change to 2. All right, and then I add another case. This time I call it expected. Actually, I just do it best case. Okay, do it best case. Still changing the same cells. This time I want B5 to be 6 and B7 to be 1. All right, and basically that's it. I can have the expected case given by default, so I don't have to add a new expected case because right now the numbers here are already at the expected case. And then I want to summarize this NPV, all right, as the result cell. So this is my result cell. I want to observe what the NPV is going to change after I put all these numbers, all right? So I hit OK. So now these are the scenario summary table. As you can see, this is my price per unit, and this is my cost per unit, and this is my NPV for different scenarios. So let me just clean this up a little bit. All right, delete that, ungroup everything. Okay, just ungroup everything. All right, see here is a current value. And, just delete all these redundant rows. Okay. So the current values basically is my expected case, and I'm going to cut the column. Okay, cut it, and then move it right here. Insert cut cells. Oh, it's taking a little while. That's okay. All right. So these are my NPVs based on different cases. And also in the Excel, in the project, it also tells you the probability of each case is a 20, 60, 20. So I'm going to put the probability there. Okay. The probability. So this is 20%. This is 60%. This is 20%. All right. If you don't like the scenario manager, if you don't like to play with what-if analysis, you can also just replace numbers here. Say the price is 3 and cost is 2, and then you will record this NPV manually and put it in a table you construct yourself. So this is the NPV, and also you can replace the price to 6 and the cost to 1. And you record the NPV just like right here. It's really up to you. Okay, you don't have to use the scenario manager function. The bottom line is you do have to provide a table right here. Okay, you do have to provide a table right here. And then after you get the probabilities and the NPVs, so you need to get the expected NPV. Okay, so expected NPV. So the expected NPV is fairly simple to calculate. It is sum of this row times this row. Okay, and then you hit Control Shift Enter. Okay. Control Shift Enter, and this should be in dollar figure. Okay, and this is called a sum of product function. You can also just do it manually by using each probability times each NPV. You get one product, and then you do it for another case, get the second product, do it the third case to get the third product. Okay, so it's the same. And to get the standard deviation, it is going to take a little bit more work. Okay, it's going to take a little bit more work. So to get the standard deviation, well, you need to get the several steps. Okay, you need to have square deviation. Okay, let's say you need to have a deviation. Number 1, you get the deviation from expected. Number 2, you get a squared deviation. And number 3, you're going to have a sum squared of deviation. Sum squared of deviation. And number 4, you're gonna get the variance, and number 5, you're gonna get the standard deviation. All right, so how do you get that part done? First of all, you're gonna use each of the NPV subtracted by this expected NPV, and this is going to be a fixed cell. All right, so I lock in the expected NPV, and then I'm going to drag it all the way. You see, each one minus the expected, and the expected will be locked. And the square deviation basically is the square of the deviation. Oops. So raised to the power of 2. That's a quite large number, but it's okay. Okay, and then you will need to get the sum squared deviation, which will be your variance. So sum squared, basically you need to incorporate all of this probability, okay, probabilities times this squared deviation. All right, so that's also a quite large number. Let's see, put it in a currency. Decrease decimal. This is basically your variance. The standard deviation is the square root of that, is the square root of this. So the standard deviation is $669,339. Okay, so that's how you get the standard deviation. You can also just use one line of Excel formula to do all the work to calculate the standard deviation. So you just do this equal, all right? And then you gotta take the square root of variance, that's something you know. And then the variance basically is the sum of a product function, which you're gonna multiply the probabilities by the squared deviation. So how do you get a squared deviation? You're gonna use each NPV minus the expected NPV. All right, that's called a deviation. Then you're gonna take the square of it. All right, so probability times the squared deviation would give you the variance after take the sum. All right, then close all the parentheses, hit Control Shift Enter. Right, you see you get the same result. Right, so now you're gonna create a chart. Okay, you're gonna create a chart. The y-axis would be the probabilities, the x-axis would be NPV. If you create a chart, let's say a column chart like this, it's not really a very good chart, or you can create a chart like something right here. Okay, so it's pretty hard to do. All right, so what I want you guys to do is to first create the data set of your chart. So you're gonna have 3 data points as the project require you. You need to have 3 columns for 3 cases, and each column should have been defined by 2 points, 1 point on the top and a point down the bottom. So what I want you guys to do is to get the column 1, which is for case 1. So you have 2 data points. One is 20%, and that's for X. That's for the Y value, and then the X value would be the NPV. All right. Okay. There's another point is 0 for the probability, and the X value would be the NPV as well. So if I do this on the chart, then you will see just insert, and chart is just do this from scratch. So insert a chart, and then with those lines, I'm going to add. Okay, select data. I'm going to add a series. Okay, the series name is called worst case. The X values would be my NPVs, which are the same, and the y values would be my probabilities. All right, so that basically is the chart I want you guys to show me. All right, and then I'm going to do it another time. This time I'm going to have 60% and 0%, okay, and 0%. And then this time my NPV will be the normal NPV, okay. Then I'm going to add another, series. This time it's called expected case. The x values will be the NPVs, the y value will be the probabilities. Okay, you will see another series is created. Now let me add another. The name is called a best case. The x values, well, I don't have it, so I better just define it first. So it is 20% still and a 0%, just copy paste. And my NPV for the best case is 1.5 million. So I'm going to use this 1.5 million twice. All right, and then I'm going to select data and then edit the best case. So this time I have the x's would be these two values, the y's would be the percentage. All right. Okay, so now I have finished creating the 3 columns. And now you may wonder, how do I make these lines presentable? Right now they look funny, right? So what you need to do here is to click, okay, left click on the line, and you will see all the options for the line. I want you to hit a line, and then the color is orange, that's okay. And you can increase the width, right, make it wider. And also for cap type, make it a square, all right? And for the joint type, also make it a bigger, all right? And for the marker, right, for the marker, you can make it disappear, right? To say no fill for the marker, so it will be gone, or no line, so you don't see that marker anymore. And you're gonna do the same thing for another line. So left click, make sure it's highlighted, and you increase the width, okay, to a satisfactory level, and then the cap ground square, joint type is liver, all right. And right here you have another one. Once again, increase this width and have a flat top, and basically that's it. You can also define this chart, and you double click on it, then Excel will pop up this quick layout, and then just do it right here, select layout 1. So the title is called a scenario analysis, and this is your legend. You can double click on it. Okay, so for the legend, you can just right click on it, and then to format legend, you want to place it down the bottom. That basically look nicer. And then just drag the chart and make it a good size. And this would be your titles. So the vertical axis, the horizontal axis is the NPV level. The horizontal axis would be the probability. Okay, so now you're finished with that. Why do we need this scatter chart instead of the column chart? So for example, if I change this number to something else, I want to change to $3 million or $30 million. And then this number will show up at the end of the chart. So it will show the magnitude of the x values. So let me just undo it. So this scatter chart is better because it incorporates the change of the NPVs. If you just use a bar chart, it will be 3 bars that are located in the same distance regardless of the NPV values.